Cellular cleanup isn't something we add to the body, it's something the body already runs by its natural workings. Last week, we looked at how sustained high protein intake impacts mTOR, the growth signaling pathway that appears to suppress this same cleanup process. This week, we consider what sources state about the mechanism itself, what cellular cleanup, autophagy, actually is, and why it needs room to work. Autophagy never fully switches off. A low baseline level runs constantly to keep cells clean. What changes is intensity. Specific triggers push it well above that baseline. Essential organs rely on this minimal, round-the-clock cleanup just to function properly. Cell survival depends on it continuing day and night, not just during a fast or a stress trigger like physical exercise. With reference to nutrients and autophagy, it is suggested that nutrient stress is a cellular state triggered by either a shortage or an excess of available nutrients, energy, amino acids, or growth factors, relative to what the cell can process. This was also considered last week regarding the potential effect of high protein intake on autophagy over the long term. According to he and others, 2018, when fuel is scarce, the body cleans house on purpose. It has to recycle to keep running. When fuel is abundant, growth signaling switches on instead, and cleanup gets dialed down to make room for growth. They're opposite triggers producing opposite effects. When energy runs low, AMPK, a cellular enzyme, flips on and tells the cell to conserve and recycle instead of grow. mTOR handles the other side. When nutrients are abundant, mTOR normally holds cleanup back. But when that suppression eases, cleanup can switch on there too. Between the two, they decide whether a cell spends its energy building new things or clearing out old ones. So they sort of work in a natural rhythmic balance under normal conditions. This is the same protein-driven mechanism from last week, seen from the cleanup side rather than the growth side. Additionally, observations suggest that not all nutrients suppress cleanup equally. Complex carbohydrates produce a moderate insulin response and suppress cleanup indirectly through that pathway. Protein, largely through leucine, appears to activate mTOR most intensely, and dietary fat has comparatively minimal direct effect on either pathway. Reasoning from this mechanism suggests a normal, balanced meal doesn't shut down cellular cleanup. It temporarily rebalances the cell toward using incoming fuel rather than recycling old material, then swings back toward cleanup once that fuel is processed. A single large or unusual meal may still be within that normal rhythm. It's sustained, ongoing extremes, chronic excess or chronic deficiency, not one meal, that potentially create a lasting shift meaningful enough to matter. The elevation may be temporary, tied to whatever triggered it, a fast, exercise, a period of nutrient scarcity. Once that state resolves and the cell returns to normal fuel availability, autophagy settles back to baseline, as it only stays elevated again if a new nutrient stress signal, low or excess, shows up to sustain it. This is where fasting windows come in. Fasting appears to do more than switch on cellular cleanup. It may also reduce certain amino acids, methionine among them, which are linked to accelerated aging when abundant, so having less around for a period may help slow that process. Fasting also seems to boost the body's own antioxidant defenses, including an enzyme called superoxide dismutase that helps neutralize damaging free radicals. In the first several hours without food, the body works through stored liver glycogen, then shifts to breaking down fat and, to some extent, muscle tissue for energy, releasing fatty acids and amino acids into circulation. Through this combination of adaptive cleanup and metabolic shifts, periods of fasting or calorie restriction appear to support healthy aging. Whether that response stays adaptive or tips into harmful appears to depend on intensity and duration. And the same review notes that calorie restriction may not suit everyone equally. In older adults specifically, the cleanup machinery itself may already be compromised, which changes the calculation. This comes with a genuine caveat too. Undereating and dehydration are real risks with calorie restriction and need to be carefully monitored rather than pursued without these considerations. Additionally, Deflefson and others, 2018, observed that, comparing trained and untrained adults during a 36-hour fast, training status changes this picture directly. Autophagy signaling markers responded differently in trained individuals than in untrained ones, suggesting fitness level itself shapes how the body's cleanup machinery responds to a fasting stimulus. Here's the balance worth holding. A 2023 review by Sharp-Kaizen and others on autophagy under caloric restriction and fasting found the response may be genuinely two-sided, based on in vivo mechanistic findings. Moderate, short-term restriction supports adaptive cleanup, but prolonged or excessive fasting can push autophagy past a useful threshold, contributing to a form of programmed cell death via excessive autophagy rather than protection. Autophagy isn't a dial where more is always better. It's a process with an upper as well as a lower boundary. So cellular cleanup isn't a supplement, and it isn't unlimited either. It's a built-in process that appears to need both nutrient availability and nutrient absence in some rhythm to function well. Here, the reference is in the context of generally healthy adults. Holistically, fasting is a deliberate practice fundamentally based on individual suitability and health status, and that's a different thing from the natural gap between meals. The ordinary stretch of time a healthy adult goes without eating before the next meal, which the body regulates on its own as a routine part of normal appetite and metabolism, which also varies individually. Subscribe. Go deeper with holistic high-performance health.